Good day everyone. I am Mark Allen S. Ronquillo, taking Bachelor of Secondary Education, major in Mathematics, studied at Libon Community College. Today I am going to teach you nor discuss to you the mathematics in the real world. Here's the learning outcomes: the parallel lines, polygons, triangle and congruent triangle, and quadrilaterals. So let's start. We go first to the introduction. Mathematics is also found in the real world. It gives us a way to understand patterns, to quantify relationships, and to predict the future. Math helps us understand the world, and we use the world to understand math. The world is interconnected. Everyday math shows these connections and possibilities. So, first that I'm going to discuss that can found in the real world is parallel lines. Parallel lines are two lines that never meet or cross each other in a given plane. In other words, lines that do not cross each other and do not have any intersection points are known as parallel lines. Parallel lines are two straight lines that are always away from each at the same distance. No matter how far you extend the two parallel lines, they will never meet or intersect each other. It helps us to understand the path of the objects and sides of the various shapes. Or, for example, opposite sides of squares, rectangles, and parallelograms are parallel to each other. In real-life examples, we often use parallel lines in professions like architecture and construction. We can see buildings that are constructed with walls that are parallel to each other. Even the ceilings are parallel to the floor, and neighboring buildings also have parallel lines when they are adjacent to one another. Notebooks are another well-known example of parallel lines, as they are filled with these lines are even parallel from page to page. So next, let's proceed to the parallel line theorems. There are two parallel line theorems, and these theorems are: Theorem 1. When two parallel lines get intersected by another line, then the pair of the alternate angles that get created are equal. Theorem 2. When two parallel lines get intersected by another line, then the pair of the interior angles that are on the same side of the intersecting line are supplementary. Two lines are said to be parallel to each other if they never meet or cross each other in plane. Lines which do not have any common intersection point or cross each other are considered as parallel lines. Here are the examples of parallel lines in the real world. Number 1. Railroad tracks. 2. The edges of sidewalks. 3. The markings on the street. 4. Zebra crossing on the roads. And 5. Railings. So let's proceed to the polygons. In mathematics, a polygon is a closed two-dimensional figure made up of line segments but not curves. The term polygon originates from the Greek word poly, meaning many, and gon, meaning angles. The polygons has a types depending on the sides and angles. The polygon are classified into different types, namely number 1, regular polygon, irregular polygon, convex polygon, and concave polygon. So what is regular polygon? A regular polygon is a polygon in which all the interior angles are equal and also all the sides are equal. There are different types of regular polygon. These are triangles, quadrilateral, pentagon, hexagon, heptagon, octagon, and nonagon. Triangles has consist of 3 sides. Quadrilateral has 4 sides. Pentagon has 5 sides. Hexagon has 6 sides. Heptagon has 7 sides. Octagon has 8 sides. Nonagon has 9 sides. The other types of polygons is irregular polygon. An irregular polygon is a polygon with a different measure of angles and side lengths. Next, convex polygon. This is a type of polygon with all the interior angles strictly less than 180 degrees. The vertex of a convex polygon always points outwards from the center of the shape. Another, concave polygon. If one or more interior angles of a polygon are more than 180 degrees, it is known as a concave polygon. A concave polygon can have at least 4 sides. The vertex points towards the inside of the polygon. I get at least 5 examples of polygon in the real world. Number 1. For triangles, I have pyramid. For heptagon, I have coin. For hexagon, I have nut. For pentagon, I have house. For octagon, I have plate. So let's proceed to the next. Quadrilateral. In geometry, a quadrilateral can be defined as a closed, 2-dimensional shape which has 4 straight sides. We can find the shape of quadrilaterals in various things around us, like in a chessboard, a deck of cards, a kite, a tub of popcorn, a signboard, and in an arrow. Next, the properties of quadrilateral. First, a quadrilateral has 4 sides, 4 angles, and 4 vertices. Next, a quadrilateral can be regular or irregular. And lastly, the sum of all the interior angles of a quadrilateral is 360 degrees. The quadrilateral can be classified into parallelograms, squares, rectangles, and rhombuses. Square, rectangle, and rhombus are also parallelograms. Here's a list of the types of quadrilateral with their name and properties. Parallelogram. Opposite sides are parallel, opposite sides are equal, opposite angles are equal. Square. All sides are equal, all angles are equal, and measure 90 degrees. For rectangle, opposite sides are parallel, opposite sides are equal, all angles are equal, and measure 90 degrees. Rhombus, all sides are equal, opposite angles are equal. Trapezoid, opposite sides are parallel, adjacent angles add up to 180 degrees. Example of quadrilateral in railway. For parallelogram, I have eraser. For square, I have Rubik's Cube. For rectangle, I have computer. For rhombus, I have diamond. For trapezoid, I have lamp. So that's it. Those objects or things that in the given example are the shape and figure that found in the railway. It is in the objects we create, in the works of art we admire. Although we may not notice it, mathematics is also present in the nature that surrounds us, in its landscapes and the species of plants and animals, including the human species. Our attraction to other humans and even our mobility depend on it. And that's all.